Hey y'all, Data Guy here. And today I have a video for you where I want to go through kind of one of the, lesser told stories in the data world, which is the data storage lifecycle policy. What happens to data after that first year, after that first 5 years, over the life cycle of a business, right? Massive organizations are generating massive, almost unthinkable amounts of data across different systems, domains, different products. And managing that data responsibly means you have to choose what data is going to be stored, how long that data is going to be kept, who can access it, and also when you're going to get rid of that data or archive it, right? You can't keep on to data forever, but there's certain data that you never really want to throw out, right? And so that's where the data storage lifecycle, combined with data retention policies, really form the backbone of modern enterprise data governance, regulatory compliance, and operational efficiency. So what I'm going to do is go through, what the storage lifecycle is, the stages of the lifecycle, what those data retention policies are, why they matter, and then also just give you some best practices and tips on how to design effective retention policies and effective data storage lifecycles. So if you like these videos, please like and subscribe. Consider joining my Patreon. It helps me out a ton. Without further ado, let's get into it. So what are the 6 stages of the data lifecycle? First, you have data creation or ingestion or acquisition. And this is the point where your data is generated. Wherever you're getting it from, this is where your data starts when it comes into your control, from an external source. Then, once you've gotten that data, right, it goes into active storage. Whether that is a data warehouse, a database, object storage, a data lakehouse, data lake, that is kind of the first landing stage of the data lifecycle as it goes into active storage. And what active storage really means is, this is data that's being moved around and stored, is being actively used and accessed. So you need both good read and write capabilities on that data. Then you're going to use that data for whatever it's being used for, transform it, process it, use it for analysis, or even for running your business, right? Some data is run on business, or some businesses run on data. And then after that, it's going to go into more semi-active and warm storage, and this is where data governance and security really starts to come into play, because you need to start saying, hey, where is this going to be? How is it going to be accessed? Now that we've got this clean, manipulated data, I don't want to necessarily, change that data or change the way it looks, but I need to make sure certain people are able to access it for certain business processes. Then, once that data is being no longer, actively used, no longer really being accessed on a regular basis, it goes into cold storage, where typically we'll jack it down to a much cheaper type of long-term storage solution that has much less read performance. And then finally, it goes to data disposal or deletion. And finally, that data is no longer necessary, and you can finally get rid of it. And this life cycle really matters because it reduces storage costs. It makes sure you have regulatory compliance. You're protecting all your sensitive data. Where it is. Where how it's being accessed. Also helps to improve performance of analytic systems. If you keep all your data in active storage, eventually those analytic systems aren't able to handle that load. So having a constant stream of data out of data that isn't no longer being used regularly is really important to keeping those systems humming. And then also make sure data is available when and where it is needed. So when you need data, you know exactly where it's going to be and how it is going to be accessed. So now the first stage, now kind of zooming in on a single stage and what you want to think about on each stage is that data creation and ingestion. And here I have a sample kind of data ingestion stage where you're bringing some data in, whether it's an event batch, right? And it can be any type of data, logs, transactional data, API ingestion. But really what you want to think about in this first stage is things like, hey, schema enforcement or schema evolution strategy. So making sure, hey, has the data changed since I last ingested it? Do I have mechanisms to actually align for that? So you can see here, you have different partitions for different batches to make sure, hey, when a new batch data comes in, it's coming in as a new partition, making sure you're capturing any metadata, so data cataloging, tags, the sensitivity level of the data, and also having secure ingestion channels and proper partitioning and routing. So, with really, really large data sets, if they're not partitioned correctly, then downstream, they're going to be really hard to access and query efficiently without blowing your costs up. And the reason why, you want to have even kind of a relatively complex ingestion strategy for really any type of data is you want to make sure you are avoiding storing any unnecessary or duplicated data. Making sure that any missing metadata is captured so you don't end up with downstream data chaos. and also compliance, right? If you have sensitive data, you make sure you're classifying that and making sure that you're accounting for that at the stage of ingestion rather than trying to fix it down the road, because it's going to be a lot harder then. So once you've ingested your data, then it's time for stage 2, active storage. And here, your data is stored in some kind of high performance system for operational use. And typically, you're going to have it in either today's day and age, in a data warehouse, a data lake, or a data lake house. So data warehouse is for, hey, if that data is going to be clean and pretty well structured, and then you're just going to take that structured data and use it for analytics, versus a data lake. That data is going to be very unstructured. You're just going to ingest the raw data, and then you're going to transform it downstream for any analytical workloads. And data lakehouse is kind of a combination of the two. But either, whatever one you choose, you're going to be using some kind of data warehouse or low latency object store like S3 or Google Cloud Storage or Azure Data Lake Storage. The really characteristics you want to think about is when you're selecting your solution for active storage is that you have high performance there, because this is where your data is going to be most commonly, very frequently read and written to. It's also going to have a higher cost per gigabyte than other types of long-term data storage. And some best practices here to apply are doing things like apply really fine-grained access control, make sure that data is stored securely and that only the right people can access the right data. Use things like column level encryption for sensitive data, so encrypt sensitive data to make sure it can't be read in plain text. And then also implement versioning and quality checks, right? So this is especially data medallion architectures are very common here, where you have kind of a bronze, silver, and gold table, and data, depending on its level of quality and how much it's been transformed, is in one of those stages. So you can actually pull data from whatever stage and whatever form you might want. But that is the general kind of guidelines you're going to want to take for this stage. So now it's time for your data to actually get used. Stage 3, the most exciting piece, where your data is getting used or altered, for ELT pipelines, AI and ML workflows, BI dashboards, feature engineering, visualizations, actually making decisions. And here, what you really want to start thinking about is, hey, tracking lineage for compliance. How are you avoiding generating redundant intermediate tables and just have, very clear ways to get that intermediate information if you need it. Also, building transformation zones in your data lake, having raw, clean, curated analytics, just what I'm talking about with medallion architectures, right, is having different stages of data that you can access without having to constantly repeat the same kind of transformations. And really the reason why you want to think about that is as your data is getting used and reused is you can commonly run into an explosion of intermediary temporary data sets where people are commonly making these very easy, common transformations, and it'd be better to just have those transformations already made and that data available in that format, as well as whatever format it's eventually getting transformed into. And also, as especially on longer timescales, this is where you want to start thinking about data drift or quality deterioration, and making sure that as people interact with and manipulate data, that it's not actually changing the underlying data values. Always have a good record of how data is being evolved and how people are interacting with that data over time. That's going to be really crucial to making sure you don't end up with a data swamp a couple years down the road. So now the next stage is warm storage. And so this is when, hey, our data is still used occasionally, but I need to go do, full, hey, backfills, I want to go access some historical data, but it's not being used for, really current decision making. It doesn't need high performance. And this is where you can take it out of, hey, that really expensive high performance database and start thinking about things like, hey, S3 infrequent access, Glacier instant, BigQuery long-term storage pricing tier. Most object storage options have a tier below hot storage where, it's going to be a bit of a medium speed to actually interact with it, right? You have cheaper drives that are actually powering the underpinning storage, and it's typically, a step away from the user. It's not something you can immediately just access. And the use cases here, when, hey, I want to take this data for historical trend analysis, for regulatory access windows, if I need to provide it to, the government at the end of the year, or, near-line ML features or model training data sets. And, this is data that, you're not going to be using it every day. And so you can have this cheaper storage that is, going to have the same durability guarantees, but it's going to have slower read-write performance because you just don't need super fast anymore. And some requirements here, making sure you have defined access patterns, and also the ability to restore to active zones on demand. So if you have data that you need to bring back up to an active zone or you need to increase the tier of storage, you have that capability, because that will happen sometimes where, hey, I need to go look at this particular legacy data set and it's really important to this piece of work I'm doing. I'm going to need to manipulate that data a lot. You're going to need to bring that into hot storage, and so having an easy path from warm to hot storage is a really good idea when you're architecting your design here. Now, the next stage we have is stage 5, which is cold archive storage. And here, on this graph of, hey, where you want to have really high, performance data for your, warm data storage, cold storage is all the way at the bottom where you have really low cost per capacity, but also really low performance, accessibility, I/O, latency, and throughput. And here is, yet another tier of storage where you'll have Azure Archives tier, GCP archive storage. There's actually tape backup systems that are still widely used for on-prem databases. And the key characteristics to look for here is, hey, once data is not going to be used unless, you need it for compliance or an audit, this data can be storage can be very low cost, very slow retrieval. I don't care if it takes hours to get this data because I don't need to access it regularly. And even immutable storage is fine here because this data doesn't need to be changed and honestly shouldn't be. It should be preserved in the state that it was, basically gone out of date with. And, data, you don't also want to archive all your data. You really only want to think about archiving, hey, what are data that I'm going to need for legal or regulatory requirements, auditing and historical record keeping, and then also, if you are going to be doing decades, analytics on decades old data, you'll obviously still want to have that data accessible. But otherwise, you can get rid of a lot of your data after it's moved out of warm storage, which is where we're going to talk about in our next stage, stage 6. So now we come to stage 6, the final stage of the data lifecycle policy. When is data going to be deleted? And here you want to think about securely removing data, and the main considerations you have is, hey, is this data ever going to be needed again? But also for things like, is it incorrect data that can't possibly be fixed? Is it corrupted data? Is it just being held just in case of, right? And here, the requirements for data disposal and deletion are going to be, basically, hey, do you need to have irreversible deletion? Can this data never be accessed again? And if so, have you made sure that you're never going to need to access it again? For encrypted storage, you're going to want to be thinking about things like cryptographic wipes to make sure that data is actually, and all the cryptographic assets are deleted from that data. Also, you're going to want to have an audit log for proof of deletion to make sure data is actually deleted, because when someone comes to say, hey, have you deleted this data? You can't show them deleted data. You have to have an audit log that shows proof, hey, I deleted this data, and then there's a record that that data was actually deleted, as redundant as it sounds. And also, having triggered automatic data deletions via policies are also another great way to do this, because it means the data has to be deleted if it meets certain policy declarations. And some of the risks of not deleting your data, right, is there's actually the right to be forgotten under GDPR. So, the EU data compliance, you need to have the right to be able to delete and get rid of all your data. Also, it increases your attack surface if you just have a lot of unnecessary data sitting around there waiting to be accessed and used in manipulative ways. And unnecessary data storage, right? There's no reason to pay for this type of data, if you don't actually ever need it downstream, right? So just get rid of it and save your company money so you don't end up with ballooning costs. So for this, to make sure that you have common standards for deleting data, that is where data retention policies come into play. And so here, for all of your different types of data, you want to have a clear record of, hey, what is our retention policy? How long is this data going to be needed to be retained for? And then what's going to happen when that data is eventually deleted? Does it need to be permanently deleted? Can it just be archived? Do we need to do a full wipe? Do we need to have an audit log for that data, right? You want to have clearly defined policies that say, hey, for this type of data, financial records, we got to keep those for 7 to 10 years. For healthcare data, 6 to 10 plus, because it's HIPAA specific, and we might actually need that even years down the line. It really is determined by what type of data you're using, but the key thing to think about is you want to have a clear definitions table similar to this, so that for every piece of data, when you look at a piece of data, you can go to a table and say, hey, this is how long this data needs to live for, and this is the life cycle it's going to follow it. And that is really all I wanted to talk about today on the data storage lifecycle. I hope you've enjoyed this video. I hope you learned something, and I hope you have a great rest of your day. Data Guy out.